Hello, everyone. Hola, obrigado. Thank you to the organizers of the Building the Future event for inviting me here today. I'm Steve Kitay, the Senior Director for Azure Space at Microsoft, and I'm very happy to have the opportunity to be here today to talk about space and to share some of the exciting work that we're doing here at Microsoft. I've had a career in the space industry, mainly on the government side. I've been at Microsoft now for a year and a half. And before I came to Microsoft, I was in a variety of positions, um, from military to civilian, working up at Congress. And in my last position in the Pentagon as the Deputy Assistant Secretary of Defense for Space Policy, where I led policy and strategy and was able to support the stand-up of the US Space Force. And then I came here to Microsoft, where we are standing up Azure Space. So I'd like to share a few slides with you. And to start with, what you can see here is there's really no more exciting time than right now to be in this industry, in the space industry. And space is a domain that inspires. And it may be for a variety of reasons. Maybe you had an experience and you remember when man landed on the moon, or when the space shuttle program was happening and shuttles were taking off and coming down. And maybe it was just your childhood looking up at the night sky, or Star Wars. Whatever the reason, it does inspire. And what's exciting now is space is changing dramatically. And I have a few graphs here just to help illustrate the trends that are happening in the industry. The first one that I'd mention is there's significant investment going into space right now. In 2020, there was $7.6 billion of private investment going into the space industry. And this is a change, and you can see the numbers here on the graph on the left, how it's changed over time. But historically, space has been driven very much by major governments. And really, it was the domain of superpowers. Now space is being democratized and made more accessible. And what's also happening is many countries and companies are getting involved in the industry. In fact, according to the World Economic Forum, over 80 countries now have a satellite in space. And what you can see on the right is what's happening with the satellites themselves that are orbiting space are much different. And in fact, there is a growing number of satellites. And I feel that this chart on the right really shows the hockey stick trend, or this major inflection point that we're at with the number of satellites going into space. And that's due to the cost of launch coming down and the accessibility to get into space going up, and the processing of what can be done on orbit in much smaller form factors is increasing significantly. So what would once take very large spacecraft, let's say the size of a smaller school bus, now in some cases there's satellites that are the size of a loaf of bread. And there's many different types, and there's many different trades to be made, and there still are large satellites and medium-sized satellites, but also small satellites now too. Now, Microsoft recognized these changes that are happening, and Microsoft's mission is to empower every person in every organization on the planet to achieve more. And we saw what was happening in space and decided that our mission is really not only to empower every person and organization on the planet, it's also off the planet as well. And what we're working on doing is really making space more accessible to everybody and the benefits of space. And how we're doing that is we're bringing cloud computing and space capabilities together. And we're doing it through a partnership ecosystem. So Microsoft is not actually building and launching its own satellites. We're partnering with others who do. And I'll talk more about that. So what we're building out in Azure Space is essentially connectivity, um, artificial intelligence, and analytics, and supporting the developer community, both on the ground and in orbit. And the foundation of what we're building out and the product that we're building, one of our key products is called Azure Orbital. And this is Microsoft's cloud fabric for space. Now, what Azure Orbital does is it brings a ground infrastructure uh, designed for space and builds it on top of the cloud. Now, when we talk about the cloud, Microsoft has our Azure Cloud, which is a massive network of compute across the globe. There's 175,000 miles of fiber optic that's strung across the globe to connect data centers in over 60 regions across the world. And each region has multiple data centers. So what this provides is this near infinite elastic compute for our customers that then within that compute, there's the most modern services and capabilities and security where customers can access these services and it can grow with their businesses in an efficient and cost-effective way. And what we've done is we're putting um, large antennas at these data centers to be able to connect to spacecraft. So for space operators, that allows them to have a global infrastructure to be able to command and control their spacecraft and also take data into the cloud to be able to process it and derive insights from it. Now, when we talk about connectivity, and we're doing that as well through not only Microsoft antennas, but partner antennas as well, including KSAT, Viasat, and USEI, which each have a network of antennas across the globe that we are linking into as well. Now, when we talk about connectivity, we're working on connecting anyone, anywhere, at any security level into the clouds, depending on what different customers would need. And we're doing that through, I'd mentioned, a partner ecosystem. So this is satellites in multiple orbits with multiple frequency bands and multiple vendors. And an example of that, I had talked about the large number of satellites going into space. One of the companies driving that is SpaceX and their Starlink constellation. And we've established a partnership with SpaceX to be able to connect anyone back into the clouds, back into the Azure cloud through Starlink. And we were also doing it with SES and their O3b mPOWER constellation, which that's in medium Earth orbit, which provides different advantages at high capacity, and SpaceX has very low latency in low Earth orbit with their Starlink constellation. And then we're also working with Viasat, which has a number of satellites in geosynchronous orbit, which is even higher, but provides more persistence in that it is at the orbit that moves at the same speed as the Earth turns. Now, it's not only about providing those connections and connecting anyone anywhere on the globe, but it's also being able to understand the data. There's massive amounts of satellites that are going into space that are not only providing connectivity, but they're also doing remote sensing of the Earth. And what that means is that there's cameras that have different sensor capabilities that are looking down at the Earth to help us understand the world around us. So what we've done there is we've partnered with Airbus, which has a number of satellites in different orbits looking down at the Earth, and to include their most recent satellite called Pleiades Neo, which operates at 30 centimeter resolution imagery, which is extremely sharp. That comes into Azure. Now, what we're doing is then also partnering with analytic providers, Black Shark, Esri, Orbital Insights, to be able to then derive insights from the data coming in from Airbus and others. And we also have our own Microsoft solutions that we're building out as well with our artificial intelligence capabilities to demonstrate what can be done with the power of the cloud. Now, we're also helping developers both on and off the planet. And I'm going to show you a video at the end of what we're doing with NASA and Hewlett-Packard on board the International Space Station. Now, I've got a video here to try and help pull this all together and do it through a scenario to bring it to life. And as we play this video, I'll speak through it, and I'm going to talk about a climate change scenario and how we believe our technology can help. So let me hit play here. And what we're going to be looking at is Lake Mead. And this is an enormous body of water, natural reservoir that spans through Nevada and Arizona in the US. And this shows how we can use Azure Orbital, as I mentioned, the ground stations, to gather the data. And in this example, you'll see Airbus 30 centimeter resolution data, which can show us how to show us the link. And of course, as you study a problem like climate change, you don't do this alone. This is an incredibly difficult problem, and it's critical to be able to collaborate with others. So what we're doing here is rendering this geospatial data inside of Microsoft Teams, and this provides an ability to collaborate with others with this whole set of best of breed technology powered on top of Azure. So um, so what you're seeing is some intelligence that's coming from geospatial data from the last 10 years. And this gives us a historical precedent of what's occurred. And now what we're using is technology from Black Shark to map out the polygons at the edge of the water. If you're trying to study a body of water using Internet of Things or traditional sensors, this is incredibly labor-intensive task. And with Black Shark, what we're doing is creating a hydrology model, which is the study of water science. And you can see here we can understand the surface area of the lake and the volume of water and the depth that's being calculated only by AI. So there's no human intervention here. And we're able to do this in this case, and we can visualize through Teams and show now the change in the geospatial data over the last 10 years. And what's really interesting about this capability we're doing is it's not only to look at what's happened in the past, but then fast forward and use artificial intelligence to predict what will happen in the future. So what we're doing here with the Black Shark algorithms is using the data stored in the cloud and queried inside Microsoft Teams to project how this lake is going to look 1 to 5 years and beyond. Now, of course, as I mentioned, this is a very challenging issue for the planet as we look at climate change. And as you look at the data, you can also see different ways and different tools that Microsoft has to understand and visualize the data over time. So as we take on challenges like climate change, that starts with having the data and being able to take action and understand it. And this is just one example of leveraging the Microsoft technology working with other partners. Now, I'm going to show another example here, and I'm going to play a video of a partnership that we have with Hewlett-Packard and work that we're doing on the space station.
Spaceborne Computer 2 is the latest available edge computing resources on the International Space Station. We had to survive the shake, rattle, and roll of launch. We had to properly package it so that it could be stored properly, and we had to come up with the instruction set on how it would be installed by our astronauts. The latency from space on the International Space Station is significant. It takes a very long time to get the data from the International Space Station back to Earth.
The space station has limited bandwidth. We are only allowed to use 2 megabytes per second for only 2 hours per week. So that means if you're running experiments that uses a lot of data, you can't send all your data down to Earth. You need to do some processing using the power of HPE's Spaceborne Computer 2. Take a look at your data and distill it down to what's interesting. Then you can send down interesting events down to Earth, where you can then leverage the power of Azure and the public cloud to process at scale. With that, we can also bring tools to bear such as Microsoft Genomics. And we take that sequencing data and see, is there anything interesting that we need to tell the astronauts about what we have seen?
One of the great things about Spaceborne Computer 2 being developed with an open source software is that here on Earth, it's really cool that for me as a developer, I can use those same tools. It really increases the developer velocity to creating something useful. So I can know with confidence that, say I go to the repository for this project, I can clone it from GitHub, I can open it in a browser with GitHub code spaces, or I can open the solution with Visual Studio Code, build it with Docker, and I have the exact same tools that I know are going to be present in the Spaceborne Computer 2. So I can validate, dev, and test locally, deploy to Azure, and deploy to space confidently. It's cool that we can take patterns that we know exist today, repeat them, stand on the shoulders of the giants that came before us, and build better things.
It's stuff that every developer knows how to work with. Building on open source components of Linux and Docker containers means that there's a much wider group of developers that can develop applications that are meaningful in space.
Open source technologies allow us to create unique and interesting things, and then Spaceborne Computer 2 gives us the horsepower to do them.
By conducting experiments with off-the-shelf technologies on the HPE Spaceborne Computer 2, we can prepare for missions that are further out. So if we're preparing to put humans on the moon or on Mars, we want to know how we can build these patterns of processing at the edge and bursting down to the cloud now while we have the space station before we go to much further and more difficult places. I'm looking forward to seeing how Microsoft brings our experience with democratizing the technology to help bring space out to every industry.
When we build these things today, our hope is that we can build truly game-changing things in the future for both astronauts on board, our partners, and the people here back on Earth.
Thank you so much for having me with you today. It was great to be able to share the work that we're doing here at Microsoft and give you a glimpse inside. And we look forward to partnering and having the opportunity to help empower you and your missions. Ciao, and thank you.